Before we get started looking at trigonometric functions and their graphs, we need to be a little bit more general and make sure we understand about something called periodic functions. Now, the technical definition looks like this. For some c, some number, f at x plus c equals f at x for every x. So what that means is that you have a graph that has a pattern and it repeats itself indefinitely. The pattern moves every c, or every however many, whatever that is, and repeats itself. Remember in preschool when you used to do those pictures and you would have a hat, a baseball, and then a bat, and then a hat and a baseball, and then you had to pick what went next, and you had to say it was a bat. Well, this is the same type thing. So we got a couple of definitions we need to make sure we know here to go with these. So first we need to know what a cycle is. A cycle is the shortest repeating portion of a periodic function. So when we said we had hat, baseball, bat, that would be one cycle of our pattern. For a graph, it's the same thing. We have a piece of the graph that repeats, and then that small piece is called the cycle. The period is the horizontal length. The horizontal length of a cycle. It's this number c here. It's how long along the x-axis we have one cycle. Now let's look at an example. We're going to look at one in your book. So this is example 1 in your book here. And you have this graph, and it's a piecewise function, and it's little horizontal lines defined on this these intervals for x. So let's see what that looks like. So here's a picture of the graph that we have. Now, we're going at 0, and then at 1, and at 0, and at 1, and 0, and at 1, and so on. So you can see that if you look from, let's start here. If we go from here at -1, at x equals -1, let's see if we can zoom in a little more. If we go from x equals -1 to x equals 3, that's where we're going to start over again. We're at 1, and then we're at 0. And we start over. We're at 1, and we're at 0. So we go this horizontal line at 1 for one unit, and then at 0 for 3 units, and then we start over. So the cycle is from -1 to 3, so there's a 4-unit cycle. So that means that the period is 4. Now, our domain is all real numbers because we're using all the x values. And our range, of course, is just 0 and 1 because that's the only y values that we have. Now, it's a 4-unit cycle, so we want to be able to see if we can write it a little bit easier than the way we had it, let's see, down here. So if you look at the bottom, it's kind of hard going back and forth between these two pages, but see how much of a pain this looks like to write out? If we write it a different way, we can use the fact that we have this 4-unit period to be able to write it a different way. Well, let's look at it. We're at 0. Well, we're at 0 from -1 down to -4, right? And we're at 0 from 0 to 3, and from 5 to 7. And we're at 1 from -1 to 0, and from 3 to 4, and from 7 to 8. Now, the easiest place to start is at the period. Now, the period is at 4, so we want to look at what's happening at 4. Well, we just finished at 1. So we're going to use that for where we're at 1. Now we need a less than, not a less than or equal to, because it's an open circle there. And because our period is 4, we're going to start with 4 times n, because we're going to, n is our number of periods, and that means that we are going to have at 4 will be there, and then at 8 will be there, and at 12, and at 16, and at -4, and so on and so forth. That gives us multiples of 4 is where we're going to be at this spot. We're going to be having an open circle at our 1. Now, how far does the 1 go? Well, it's 1 unit less than that. So we start 1 unit less than that, so that's 4n minus 1, and we go up to our 4n. Now, when we have drop down to 0, we're at this place here, and we're actually equal to it this time. So that's our 4n minus 1. And then how far do we go from there? Well, we're 3 units less than that. So what's 3 units less than this? Well, we subtract 3 here, and that's where we get the 4n minus 4, because the minus 1 and minus 3 go together to give us the minus 4. So that takes a little bit of thought and kind of a little bit of understanding. So make sure that you kind of pause and look at this example in the book, and make sure you really grasp how we get this and why we do this. Read over the section, listen to this again, try to figure out how we got that. Make sure you understand that. Okay, you want to look at the cycle. So it's a 4-unit cycle before it repeats again. So the 4 units mean that that's the period, which is going to give you this number here, so that we can work backwards and get the whole cycle in. Remember, this n is whichever period, whichever cycle you're at. It's the number of periods. So this is the first cycle here, so this is when n equals 1. And right here we start the second cycle, so that's when n equals 2. And then we'll start the third cycle, that's when n equals 3. And this is the negative first cycle, so n equals -1, and so on and so forth. Or actually, I guess that would be the 0 cycle. The 0 cycle. So look over this, pause it, make sure you've got this, own it, and then we can move on. All right, now why do we need to know this when we're talking about trig functions? Well, because trig functions are periodic. Now, we've already talked about that trig functions use right triangles to find information about angles. And we talked about angles, and remember when we drew circles and we said that we could call this angle by this measurement, or we could call it by going around and then again, or we could go around a couple of times, and it'd still be the same angle. And then, so it still has the same sine and cosine with those reference angles we talked about. Remember that? So the reason it's periodic is because you can keep going around these circles and finding the same things. We're going to do a little activity in class to try to help solidify that understanding. But for now, make sure you understand that the trig functions are periodic. So let's look at a couple of examples of what this means. Let's say we want to find the sine of 61 pi over 3. Well, that's pretty huge. If you get this into a mixed number, that's 20 and 1/3 pi's. Now, how does that help us to know that it's 20 and 1/3 pi's? Well, remember, around the circle is 2 pi radians, right? It's 360 degrees. So 2 pi radians is around the circle 1 time. So how many times is this around the circle? That's right. It's 10 times around the circle. Plus, then we go pi over 3 more, because this is 20 pi plus pi over 3, right? So this is our 10 times around the circle, and this is our pi over 3. So this is going to be equal to the same thing as sine of pi over 3. Because we've got this angle here is, we could call it pi over 3, or we could call it 61 pi over 3, because we went around the circle 20 times or 10 times and ended up pi over 3. So since we know what the sine of pi over 3 is, because you've already memorized your unit circle, we have that it's the square root of 3 over 2. So the fact that this is periodic means that we only have to memorize the unit circle. And realistically, we only have to memorize the first quadrant, but we've already talked about that. So the big thing you need to understand is, because it's periodic, you only need to know the 1 time around the circle, and then just figure out how many, where you end up as you're going round and round the circle. Let's try one more. What if I have the cosine of negative 85 pi over 6? Well, what's that equal to? So let's think about this. What is that in mixed numbers? That's negative 14 1/6 pi. So that's negative 14 pi minus pi over 6, right? So what does that mean? That means we went backwards around the circle, because remember, the negative tells us we're going clockwise instead of counterclockwise. How many times? Right, 7 times. That's this right here. And then we went an additional negative pi over 6. So what we did was we started this way, backwards. 1, 2, 3, 4, 5, 6, 7, and then we went an additional pi over 6. So here's our angle. So if we want to know what the cosine of negative 85 pi over 6 is, really all we have to look at is the cosine of negative pi over 6. And because you have the unit circle and you have it memorized, you know that the cosine of negative pi over 6 is square root of 3 over 2. Let's try one last one. What about tangent? Tangent is also periodic. Remember, tangent is sine divided by cosine, so we can use that to be able to use our unit circle. So, what if we want to know the tangent of 21 pi over 6? So we put this in mixed numbers so we can see what we're doing. So we have 3.5 pi. So this would be the same thing as 2 pi plus 3 pi over 2. This is 1.5 pi, right? Now, why didn't I use the just 3 pi here? Right, because that's not a whole time around the circle. We only want even times around the circle here to see what we're left with. Now, you could have said, I'm going to go around the circle 1 whole time, and I'm going to go around the circle half a time more, and then I'm going to go pi over 2. It would be the same thing. Because look, go around the circle 1 time, and then go around to 3 pi over 2. We'll put you there. Or we can go around the circle 1 time, go around the circle half a time again, and then an additional pi over 2. Either way, you end up in the same place. So if we've got this 3 pi over 2 that we have on our unit circle here, then we can use that to figure out what the tangent is. Now remember, with our unit circle, we only have sine and cosine. So we use the fact that tangent is sine divided by cosine to be able to figure this out. The only problem is here, what's the sine of 3 pi over 2? It's -1, and the cosine of 3 pi over 2 is 0. Of course, this causes us a problem, which means that this is undefined. When we look at the tangent function, you'll see that it has vertical asymptotes at places where the cosine is equal to 0. and you'll have some places that are undefined for the tangent and the cotangent. Now, in your book here, on page 131, you have some identities that will help you. These are period identities here on the left-hand column. And basically what it tells you is that sine, cosine, secant, and cosecant have a period of 2 pi. What that means is when we look at those graphs, they repeat every 2 pi radians. One time around the circle, and they're repeating. Now, tangent and cotangent repeat half a time around the circle. So their period is only pi. Now, the other thing is a cofunction identity, which you'll look at a little bit in your assignment, and you can look at an example in the book. And basically it's showing, remember that in a right triangle, the two acute angles have to add up to be pi over 2, or 90 degrees. And so the angles that are the complementary angles of each other, the sine of one is equal to the cosine of the other, and so on and so forth. So make sure you look at this with the examples in your book. Now, the other thing you need to remember is that we need to remember about even and odd functions. Just as a little reminder, you need to remember that an even function means that f at negative x equals f at x, and an odd function means that f at negative x equals negative f of x. Now, the reason you need to remember this is because sine is odd and cosine is even. Now, if you think about this, when you look at the unit circle, you can see that this is true. If I have an x value here, then I take that negative x value, then the cosine is going to be, if I have this x value, rewind. If I have this x value, we're talking angles here. If I have this x value, then I take a negative one here. We know that the cosine is our x coordinate on the unit circle. So whether I'm taking this angle or this one, I'm still have positive x values for my positive cosine values. Probably be easier if we call this theta. That's going to be really confusing. Okay, so if we have these angles, theta and negative theta on our unit circle, we know that the cosine is the x-coordinate of the point it goes to on the unit circle, so these x-coordinates are going to be positive. So that means that they're equal. The cosine is equal whether you're using theta or negative theta. Now with sine, of course, the y values of the point that it goes to on the unit circle, so the theta and negative theta are going to have opposite signs because the y values are positive up here in the first quadrant and negative in the fourth quadrant. So we'll talk about that some more, but you need to look at that on the unit circle. But this section, periodic functions, you need to make sure you understand what a periodic function is, what its cycle is, its period. You need to be able to look at some examples and figure out what kind of cycles they have. For example, a pay cycle even, you get paid every 2 weeks. So that's a period of 2 weeks. And if you're writing a function, you would have f at x plus 2 equals f at x because your period is 2 weeks for a pay cycle. And other things like that. And you need to remember about trig functions and the unit circle. Make sure you know that unit circle. It should be memorized by now. And make sure you know it in degrees and radians both, and all the points. Look up on page 131 at those period identities, especially the period identities, so that you know what the period, that sine, cosine, cosecant, secant all have a period of 2 pi, and tangent and cotangent all have a period of pi, because the next thing we're going to look at is their actual graphs and work on those. So make sure you've read section 3.4, written down any questions that you have, and looked over this stuff, maybe paused, replayed, figured this stuff out so that you can have a solid handle on periodic functions.